This pi bond is a very nice pi bond. One of the questions I get asked a lot as we wander through resonance land is, how do I know if this molecule has any resonance contributors? Today, I'd like to share with you a pro tip on what to look for in structures to see if there's any resonance contributors that you can draw. What are the patterns that OChemNinjas notice to know that this structure does have additional resonance contributors? The three structural features that you need to watch out for are lone pairs or radical electrons, positive charges, and pi bonds. If you see in a molecule any two of these three structural features adjacent to each other, then you know that you can draw resonance. So the pattern that you're on the lookout for is two of these three structural features adjacent to each other. Any molecule that has two of these three features adjacent to each other will have at least one additional resonance contributor. Let me talk a little bit more about the pi bond here, because the pi bond can have additional resonance contributors all by itself, even if you don't see the other elements right away. What do I mean by that? If you have a pi bond, you can take that pi bond and break the pi bond and localize those electrons onto one of the constituent atoms. This will draw a resonance contributor where you have just the single bond between the two atoms and a lone pair negative charge on one side and a positive charge on the other side. This is a complete resonance series for this pi bond. Starting with just the pi bond, even though we didn't have any of the other elements, we were able to draw an additional resonance contributor. But what I want you to notice is that this additional resonance contributor does fit our any two of three pattern. We have a positive charge adjacent to a lone pair, so this does fit our resonance pattern. We could take this lone pair, deposit it on the bond between the two atoms, and that would give us back our pi bond. We can do this with carbon-carbon pi bonds, but honestly, we see it more often with things like carbon-oxygen pi bonds or other heteroatoms like nitrogen or sulfur, where we can break the pi bond and put those electrons locally onto the electronegative element, the oxygen in this case, to draw a charge-separated pi bond with the oxygen with three lone pairs and a negative charge, and the carbon with a positive charge. This is really more where you would see the charges separated on a pi bond. But I do just want to make you aware that if you see an isolated pi bond, you can technically draw additional resonance contributors. We don't usually, unless we see one of the other structural elements adjacent, but you can. So in a very simple case, if we have a lone pair adjacent to a pi bond, I can take that lone pair, make a new pi bond between carbons 1 and 2, and break the pi bond to make a lone pair and a negative charge on carbon number 3. This is a situation where we do have an additional resonance contributor because we have two of the three elements adjacent to each other, a lone pair next to a pi bond. Here we have a situation where we have a positive charge adjacent to a pi bond, so we can draw an additional resonance contributor here. This video isn't about how to draw these additional resonance contributors. If you would like to see a video about that, I have a link to that down below. We can take the lone pair in the pi bond and do a bond to adjacent bond arrow to switch the pi bond over to form a new resonance contributor where we have the pi bond inside the ring and the positive charge outside the ring. Now, we have this other pi bond on the left side of the molecule, but it is not going to be involved in this resonance series. These are not adjacent to each other. We have the positive charge, but there's an entire sp3 hybridized carbon in between before we get to the other pi bond. So this pi bond is a very nice pi bond, but it's not going to be involved in the resonance with the right side of this molecule because they are not adjacent to each other. Here's a situation where we have a lone pair negative charge adjacent to a positive charge. We can draw resonance contributors. We can take the lone pair from the atom with the negative charge, drop it down as a new pi bond between the nitrogen and carbon, and that will give us an additional resonance contributor with a nitrogen-carbon pi bond. These are the structural patterns that you'll want to watch out for if you want to be an OChemNinja when it comes to resonance.
Thanks for watching. If you like what you saw today, maybe let your instructor know about these videos, or your friends at other schools. Check out some of these other videos and playlists, see what you like. As always, don't forget to like and subscribe.